All right, so I want to cover something a little bit different than what I normally do. And that is basically how to write a smart contract that can interact with your ArcGIS API for JavaScript application. Right, so if you're not familiar with it, smart contracts are deployed to a blockchain, in this case, to a local Ethereum blockchain, and they kind of act like a immutable database, right? In a way, because you can actually add functions to the contracts that'll let you update something inside of them. But once that's done, and maybe you're done updating it, it can never be changed again, right? So that contract lives out there, completely immutable. You can use it to validate information. There's a lot of really cool technology being built on these right now that I think there's projects that have some real utility to them. No, not Dogecoin. Dogecoin's fun and all, but it's not really a project of utility, right? So most of the time when you're dealing with blockchain and smart contracts, you're going to hear about things working in the financial sector of some sort, right? DeFi, decentralized finance, something like that. But I think there's other use cases for it out there. And there's been a couple of projects that have implemented blockchain on GIS in some way or mapping in some way. There's a foam, which is kind of interesting, where you basically have a point of interest that you can add to a blockchain, right? So you add that point of interest there, then there are parties, people that are holders of the coin, can called cartographers, that can vote on, you know, the validity of that point of interest, right? I don't know exactly how it all works. I looked at some of the foam docs in the white paper, but just check it out. So that's an interesting project out there, but I want to try something just pretty simple, just give you a quick introduction to how you might be able to write a smart contract to interact with your mapping applications. Okay, so first off, I'm going to be using Truffle and Ganache, which are part of Truffle Suite, which you can see here. And Truffle is actually designed to help you quickly get up to speed with building out decentralized application, DeFi app, right? And it comes with a library that you can install called Truffle. Part of the suite is also Ganache, which is really neat. You basically can download this and run a local blockchain that you can interact with, right? Because you need to have, in our case here, we're going to be working with Ethereum. And every time, that's kind of the thing here, when you deal with these blockchain applications, when you make a transaction on the blockchain, anything that's going to create a contract or update it in any way, or transfer funds or something like that, requires some sort of a fee, and it's referred to as gas, right? And this is a gas fee to use the network. So you need to have something in place here. So we're going to have a local version of the Ethereum blockchain running on my machine here, and I can add that in here into my MetaMask wallet and use it there. Okay, so basically what I'm going to do here is I've got set the dev account, yeah, Ganache dev, and I've already added the Ganache dev network in here. And the way you can do that is if I go to expand the view, and we go ahead and look at, where is that? Settings in here, go to networks, and you add this Ganache dev network in here. That's what I called it. Give an RPC URL, so it's just going to point to localhost. So this URL is going to match what is in here for this RPC server. And the chain ID is going to be LEET, right? 1337. The symbol I'm going to use is going to be ETH. There's no block explorer because it's a local blockchain, so I'm not going to be able to explore the transactions in that case. I don't think there might be a way to get a block explorer off of Ganache here, but I don't know. If I need to, I can just look at the transactions here in Ganache myself if I want, and that'll be fine. You can see I'm doing a lot of different work in here to try to see how that works. So, okay, so that's pretty much what you do there. So you install this MetaMask wallet, which is a browser extension you can use that can hold your tokens and stuff, and this is what you would use if you're going to be doing any sort of development with blockchain stuff, right? So the next thing you need to do is you want to install Truffle in your project, right? So you can install it globally, which works out pretty well. There are also these Truffle boxes you can use, and I don't think all of them are completely up to date, right? There's like a React Native, there's a React and stuff, there's a Webpack version. I tried a couple of them, but they seem to be a bit outdated here and there. So I don't know how totally up to date all of these are, but you can definitely take a look at some of these projects to get a good idea of how you could configure them. And they're not difficult to configure once you wrap your head around how you're going to write the contracts and basically tell it to point to your local Ganache blockchain to deploy those contracts. That's where the bulk of the complexity comes into play here when you're working with it. So let's just dive right into writing a contract, right? So you're going to go ahead and want to use, you are going to be using Solidity, which is the programming language that you use to write smart contracts. There are projects and libraries out there where you can do it in JavaScript, for example. You can actually write smart contracts just about any language. It doesn't have to be Solidity. The idea is that it just needs to compile down to something that can be deployed, right? But Solidity is by far, I think, the most popular language to use. It said it's influenced by C++, Python, and JavaScript. I definitely buy the JavaScript part and some of the C++. I'm not sure totally. I don't know. I haven't done a lot of Python in a long time, so I guess there's some Python in there. I think it feels a bit kind of JavaScript, Java-ish, right? To work with it, but it's nice. It's not too bad. I like it quite a bit. So you can test your contracts out on this site called Remix. So remix.ethereum.org. And I've already got started here by adding one. And you can also go ahead and look at some of these sample contracts they have in place here, so you can get kind of an idea how they work, right? So you basically use keyword contracts to say create a class, right? So contract storage. You're going to provide some variables to it and some functions. And these functions are going to go ahead and interact with the contract, right? And there's also an owner. We're going to do one a little bit closer to something like this owner in here. And you can work with events, right? So you have an event keyword that you can use, and then you can emit that event. We'll talk a bit about how the require and stuff works in here. So let's go ahead and get started writing out a contract, right? So I'm going to create a contract, call it GeoAsset, because it's basically going to be a way to track an asset that you're adding to your GIS data or something like that, right? So this contract is going to have a few properties. I'm going to have a string called a global ID, and I'll explain why I'm doing that in a minute. When we get to the application, we have address user. Address is basically the like your token address, like you as a user, your wallet address, that would be your address. And there could also be like contract addresses and stuff. So in this case, it's going to be us, whoever we are. We're going to be the user being added to this particular contract. So now I'm going to have some public properties. I'm going to have a public lat, which would be my latitude, and a public, lon, which would be my longitude. And then I'm going to go ahead and create an enum for statuses here. Statuses. And I'm going to have a created and a complete. Those are 2 steps to my contract. I'm also going to go ahead and provide statuses as public, and we'll call that just status, like so. So that way I can check on the status of this contract at any time that I want to interact with it, right? I'm also going to want to emit an event with this, and I don't know if I'll actually use this in my application itself, but it is kind of nice to have. Oh, we'll use it. No, I don't want that. I want this. That's what I want. After doing some stuff with the contracts and whatnot, every now and then it's kind of nice to have access to an event. so that I can watch what's happening with the contract during the life cycle of my application. So I don't mind just adding it from the start. So I gave it a string. I'll go ahead and provide the let's call it status. Yeah, that sounds good. Actually, no, string name. So the name of the action, I'm going to go ahead and emit the address, and we'll call this account, right? And this is going to be, me or whoever's interacting with the contract, right? And then I want a timestamp. So uint timestamp. So these are the kind of basic types you get when you're working with contracts. It's important to note here, and there's the reason I made, okay, let's talk about this for a second here. The reason I made the latitude and longitude string is because Solidity does not support decimal places for numbers, right? It doesn't support numeric decimals. And you might be wondering, well, that doesn't make sense. If I have like 99.99 Ethereum, how does it know that? And actually keeps it as a very long number, and then it converts it using a method called WEI, I think is how you would pronounce that, right? And you pass it a very large string of the like 99, 99999990000, whatever, and it will turn that into the value, right, that you're looking for. And I can't remember how many places it goes to, but that's kind of how that works in Solidity. There is no support for decimal places. So what I'm going to do is I'm just going to hold the value of the latitude, longitude, a string in here, and work with it that way. And further down the line, I'll cover, maybe in another video or next week or something like that, I'll talk about some other cool things you can do with contracts. I think are really nice. Okay, so now I want a constructor. So for my constructor, I'm going to pass the latitude and longitude the moment I create this contract, right? So pass string, and I just use the common use case I see when you're working with arguments is that, like, if I want to pass something that's going to populate the lat property, then it's underscore lat, or name, it would be underscore name in the arguments. Just it seems like it's a very easy way to get this done. And I think I've seen this done in other languages before. I think I've seen this done like in C and stuff like that. And I don't know, it's just kind of a convention that is used, right? So that's kind of weird. I didn't get an error here, but it's okay. Normally what you do when you're working with strings is you pass a, let me actually save it, see if it complains. Yeah, it's complaining, right? So the complaint here is that must be storage or memory for constructor parameter, right? So you need to pass a memory keyword in here so that it can store this string when it's interacting with it. And they have to say it's going to be a public constructor. It'll complain about a public constructor here just as a warning, but I found that if I don't put it, then it doesn't compile for me. So yeah, I still don't quite know what I'm doing when I'm writing these contracts. So I'm probably very dangerous at writing contracts at the moment, but it's okay. Trust me. Ha, famous last words, right? So, okay, so here what I'm doing is I'm saying that I have the address for my user is going to be equal to me, who is interacting with this contract. So there's a global message variable that you can work with, and you can find out who the sender is for this contract. So when I go ahead and deploy it, or I go ahead and interact with it, the message.sender would be me, or whatever my wallet address is that I'm using for MetaMask up here, right? So that's how that works. So now I can go ahead and say that since I'm just starting this contract, the status is going to be equal to statuses dot created, right? So I just create the contract. Lat is going to be equal to lat. Lon is going to be equal to lon. That was to say lat, didn't you? And at this point, I'm going to go ahead and emit my event. Emit the action. Yeah, action. And I'm going to go ahead and pass the, I think let me do this. Let's see, statuses dot created along with the user, right? So that's whoever was interacting with the contract. And I want the timestamp. So the way you can get timestamp is Solidity. It used to be you would use the keyword now, but this is not how you would do it today. The way you do it today is going to be block dot timestamp, right? So you're going to get, you have a global property of the block, and this is going to be the block that you're working with, the blockchain, and you're going to emit that. So it's complaining here. Yeah, so it's not going to let me go ahead. It's not going to let me use the enum for this. Actually, you have to use the created keyword there. Okay, great. So once I create the contract, I only want one other function here that's going to update this contract. And the workflow I'm thinking here is that when I edit a feature layer, I'm going to just working with points. I'm going to pass lat long to this contract. When the feature layer has been updated, I'm going to get the global ID and update this contract with the global ID. So this contract is going to be immutable for that particular interaction I made with my feature layer at that point. It's silly. I know it probably is not super useful, but again, I am just trying to play around with different use cases for something like working with smart contracts with the ArcGIS and JavaScript API and everything, right? So, okay, so let's do a global ID. So I'll pass that in. That's gonna be my update. It's a public method, right? And so, okay, so let's go ahead and just do this here. Let's go and say global ID is going to be equal to global ID, and say status at this point is going to be equal to statuses dot complete, right? So it's done. And now I'm going to go ahead and emit my event action, and the action is going to be complete, and it's going to pass again the user and the block.timestamp like we did before, right? Bam. Okay. Problem with this, I'll tell you right now what the problem is here. This is completely, the smart contract is completely vulnerable to attack at this point. Because now somebody could come in here, get my contract, you know, maybe get access to my wallet or something, or I interact with this contract after the fact, and I could just change the global ID, right? And remember, smart contracts should be immutable, have immutable state, right? Meaning that you can't change state once it's been updated, unless you have functions like this in here to do it for you, right? And there's plenty of examples of smart contracts with methods that can, you know, do different updates and whatnot, or change something inside of here. But I don't want it to after this. I need this to just stay and not be able to interact with it anymore after that. So how would you do that, right? So you might think, okay, I can go if global ID equals global ID return or something like that. You might do something, think about doing something like that in JavaScript. Well, let's do a couple of things here. In Solidity, they actually use the require keyword to do these kind of checks, right? So I'm going to require that the message.sender is equal to the user, right? Meaning that I'm the one that created the contract, right? I own this contract, so I should be the only one allowed to run this update method, right? I'm also going to go ahead and require that the status is equal to statuses.created, right? Meaning that even if I am the owner of the contract and I come in after the fact to try and change the global ID, even though I don't want it to be changed, I want to make sure that if I've already completed this contract, as I've stated down here, then, you know, I need it to only be equal to the created one, because that's what I did over here. So if it's complete, it will let me get past this step, and this contract will get rejected, right? It'll error out when you do it. So, okay, we've got that. So now in Remix, I can go ahead and I can check these warnings, and it does give me a warning about the constructor being non-deployable, making abstracts. I don't understand it. I don't know why it's doing this, exactly why. I have an idea, but it doesn't seem to impact the contract at all when I compile it or deploy it, right? So, okay, so I can compile it, and again, it's just gonna give me that warning here. I know it's okay. Now I want to deploy this contract. But remember, when I deploy it, I need to pass lat and lon to the constructor. So I can do that in here, and the deploy tells me I can do it in here, right? So I'm just going to say 34.22, and let's just say negative 118.34, like so. Now let's go and deploy it. Ignore publish to IPFS. Maybe I'll cover this in another video down the road, how to use IPFS with your contracts. I think that'd be kind of interesting. But for now, we'll just leave it at that. So here's my deployed contract. And at this point, I want to update this contract, right? So, okay, let's check the status, right? Status is 0. Okay, so let's just go ahead and call the underneath that. Lat lawn. So those are both the values in what's the constructor. Status is equal to the first enum, so it's created. So now I need to go ahead and update the global ID. So let's just say the global ID is ODOE 123. All right. Then update it. Bam. Check the lat again. Check the lawn again. Check the status. Status is now 1. Right. So it's the next enum. It's completed. I should no longer be able to update this. If I run update here, I should get a. Did I make this bigger? There we go. Yeah. So it errored out. Yeah, it just told me that this transaction has been errored out, right? It's been reverted to its initial state, blah, 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 because I can no longer update it anymore. This contract is now completely immutable, can no longer be updated anywhere anymore, right? Awesome. So this remix.ethereum.org is a great place that you can go to just to kind of test out your contracts and everything like that. If you want to, you can go ahead and do the injected Web3 or so, and it would go ahead and pop up the MetaMask confirmations every time you interact with it. But I just recommend using JavaScript VM option for the environment, that we don't have to deal with the whole MetaMask nonsense at this point, right? You shouldn't have to in here. I don't think it's necessary. So, okay, so I'm going to copy this, because why not? Let's go to my app over here. And what I've done here is I have Truffle. This is a create React app, just pretty simple. I installed Truffle already, and when I have Truffle, there is a, oops, let me go and close this, open this up again. Okay, there we go. So the Truffle config basically has some options in here. You basically tell it that it's a development network. It's pointing to localhost. There's my port, exactly the same stuff that was in Ganache over here. And then I need to tell it where my I want my contracts to get deployed to. So by default, it's going to look for contracts here, right, in this contracts folder. But I want them deployed when they're built into this folder. And we'll take a quick look at this JSON in a second here. So that's where they're going to go. And then some options with compiler. Just someone use a Solidity compiler, enable optimizer, enable true. And then I don't even know what this runs 200 is. I didn't check that, but I have seen this little bit in samples before, and you probably don't even need this, but I just left it in here because why not, right? So okay, so now I go up here to contracts, and here's my contract I had over here. So I'm just going to go and copy everything I had there into here, save that, and we're good to go. So let's check on this migrations one. So the migrations part is basically what's going to go and migrate deploy my contract for me. Now this may error out for me because, again, I'm not sending the when I deploy it here anyway. I can compile it, but if I try to use the migrate and deploy, it wouldn't be passing a lat long, so it would fail in that part. It would migrate it, but it wouldn't be able to actually deploy it. So I'll put this project up on GitHub later on. You can try it out. If you get that error, you run a Truffle Migrate. That's all it means. Just run Truffle Compile, and you should be okay, because we're creating a new contract every time we're going to go ahead and add a point to the map. So that's what's in the contracts folder here. Now the migrations folder, okay, has these files in here, and I think these are read by Truffle by this steps, right? So one is the initial migration, right? So it's going to require this migration Solidity file up at the top there, and it's going to go and deploy those migrations for me. And it's going to go ahead and know what to do with that based on what other contracts are in that folder I have. And there's a deploy folder here that's just going to go ahead and deploy it for me. And again, I don't, for my geo asset here, I don't think I need it, but again, this could cause an issue if you're just building the projects. You see here, assign token to variable to get its address, right? Well, we're not going to have the address until we deploy. We'll deploy it inside the application when we work with it. So just give you an idea of how that works. So make sure I'm using, I was working this project with Node 1416. I can run Truffle compile, and that should just work. Cross my fingers, right? Yes, that works. And then to actually deploy it to the blockchain, I would run Truffle Migrate. Now, this might work on my machine because I've already done it multiple times to this particular blockchain, but I think if I removed this copy of the blockchain I have on my machine and then create a new one, it probably would not work because, again, I am requiring now to have a lat long pass to the constructor. That means I have to update this code, I believe, here when I deploy this token if I want to deploy it that way. But we're not. Again, we're not going to do it that way. We're actually going to do it inside the app. So, okay, so that's basically that, right? So now, if we look at the actual code, what it is I want to do here. So this is basically an application that is going to go ahead and let me work out. It's basically the same app that is in the JavaScript API. Come over here, go to samples, go to edit, and I'll just find everything tagged edit. And I believe it's going to be, where would it be? Apply edits, maybe? Oh, this one. This one's all filled. So I've been messing with this one hard, right? So it's basically this demo here that I'm going to be messing with in my application, right? So I've already got some boilerplate in here, but not everything, right? So you see this Web3 state and set Web3 state. One of the things that you're going to want to do here is use a library called Web3 Js, right? So if I come over here, Web3 Js, right? It's a lot of documentation on here. There's a lot that it can do. I have barely scratched the surface of the most basic things you can do with it, but it's kind of fun. I'm digging it, right? So you can npm install it, work through your app. So this is a Create React app. I tried using it with Vite, but it looks like this Web3 uses some Node, native Node libraries like util and stuff like that, process and whatnot, that Vite does not support. You'd have to add some roll-up plugins and stuff for Vite to do it. Seems to work just fine in Create React app though, so don't worry about it. So I've already got that installed here. I already did npm install Web3 here, so I don't have to worry about it. So if I come over here into this project here, we're going to go ahead and we're going to import a couple of things here. And excuse me for having some copy paste stuff done because a lot of this code is pretty hefty, man. I'm telling you. Okay, so what I am doing is I'm importing Web3 from the Web3 library. I'm importing my GeoAsset from the contracts GeoAsset JSON. So this is the JSON file that gets created when Truffle compiles this Solidity file here, the SOL file. So when it compiles that file, you get something that looks like this. It's a pretty large JSON file. It's called an ABI. And I forget what ABI stands for again. It's kind of like an AS tree, right? Like an abstract syntax tree in a way, because it tells you what the inputs are going to be. It's going to tell you how you can interact with the contract. It's got metadata associated with it, bytecode. Here's the AST stuff actually in there. But it's got information about the contract itself and how it's going to interact with the blockchain, right? So you need that if you're going to work with that in your project. So you're going to import that here. So JSON file, the Web3 file. And I've got a couple ways to update states. I'm going to store some stuff inside my state. Then I'm going to go ahead and update some of that state as well. So you can see here, I've got my, I'm getting the contract, the account, and Web3 from this Web3 state. And when the application loads, I have a method here called load Web3 that I'm going to run. And then when it updates the Web3 state, I'm going to go and load the map. And then just display the map here. So let's look for the load Web3 code up over here. So all right, so how does some of this work? What are we going to do? So I've seen a few different ways that people kind of load the Web3 library, check to see that MetaMask is installed in the browser and so on. So I'm just going to go with the way that I did it and the way that I've seen it done. So I'm going to do it like this. So I'll do if, let's do it like this. If type of, window.ethereum spell it right, Ethereum is equal to undefined. Then I want to go ahead and alert the user. I'll be like, dude, please install MetaMask. And I think it could pretty much be like Trust Wallet or any other wallet like that too. I only know MetaMask and Trust Wallet, but I know there's a couple more. And then just return, because I'm not going to do anything at this point, right? So, okay, so that's just like a quick way to make sure that they've got the proper wallet installed. Now, if they do, then I know I can interact with it. So I'm going to go ahead and enable that by using a method called enable. Right? And again, this is on in the browser already, right? So if they have this already installed, then these globals are already there for you to be able to interact with it. Now I can go ahead and create a Web3 instance I can interact with. So now I'm going to go ahead and say that const Web3 is going to be equal to a new, what am I doing here? Web3, and I'm going to pass window.ethereum. Now, there are other ways you can create this Web3 instance. So if you know the actual URL that you are going to use for the provider and stuff, you can do that. And there's a lot of different ways to do it. This is just like the simplest way I found to get up and going real easy, right? So now I want to get the accounts that are on here. So const accounts are going to be equal to, and with Web3, all this stuff is promise based, so you can be using async await a lot, right? So I'm going to await Web3, no, I didn't spell it right, Web3 dot ETH dot get accounts, like so. All right, so now I have all the accounts listed, but really I only need the first one to interact with. So account equal to the first one, accounts. Right, so because that should be the one at the, whatever one you currently have selected should be the one at the top. This would also be where you would go and say, hey, you know, you're not using an Ethereum account. You're using maybe using an account on the Binance Smart Chain or on the Matic, or I'm sorry, it's on Polygon or something else, right? And you can alert the user, hey, switch to the right blockchain, so we can go ahead and get things going for you. Okay, so I got my account now. So now what I want to do is I want to create the contract that we're going to be interacting with, right? So this isn't the actual contract we're going to deploy. This is just, I need a contract address to interact with here. So let's do that. Let's do const contract is going to be equal to a new web3.eth contract. It's capital contract. And I'm going to go ahead and pass the ABI of my JSON from my contract, right? So there we go. Now at this point, actually let's get rid of the space here, clean this up a little bit. I go and update the state for my account. Now actually what I want to do is if I want to update the state if I have an account, right? So if I don't have any accounts for whatever reason, then I don't want to do it. So if I have an account, let's set web3 state, pass an object, pass the account, we'll pass the contract, and we'll pass web3 so that other parts of my application can interact with that. Okay, that's kind of a bit, right? I mean, I'm sure someone's already written like a React hook that you can use for all of this Web3 stuff and everything. Don't worry about it. It gets a little easier to start interacting with it and start working with these and whatnot. It took me a little bit to kind of get my contract working as I wanted it to. But yeah, it's not so bad. Now I've updated the Web3 state. The use effect hook for when Web3 state gets updated is going to load, which is going to be loading the map. Right, so everything's getting loaded here, and then the interesting bits happen when I click on the map to get my point. Right, so when I click on the map to get my point, here's where I want to start doing some stuff. Right, so what I'm going to do is we're going to go in here. So when I get that, I have the lat and the long now. I want to create the contract that I'm going to go ahead and deploy to my my application, right? So let's do, okay, so we're gonna deploy this contract. There we go. Yeah, let's do it like this. I'm just trying to think of the best way to save some stuff here. So I want the contract address. When I deploy it, it's going to return an address for me that I can then use to retrieve that contract from the blockchain later on, right? So let's go and do this. So now I've got my contract address. I'm going to go ahead and do, again, it's another await on that contract. Now I'm going to deploy the contract. I need to pass some information with this contract when I deploy it. So what I want to do is when I deploy it, the data is going to come from my JSON file again from my Solidity contract, and it's going to be the bytecode, right? And I need to pass some arguments now. So the arguments I'm going to pass are going to be the latitude, longitude. But remember, I want to pass them as strings. So I'm going to pass them as toString. So lat, and remember, I get them in the right order. Don't go jacking up your lat and long, right? You don't get help here in terms of IntelliSense for that. All right, so now it's long.toString. Bam, there we go. So I'm deploying my contract with those two arguments. And this is just getting ready to deploy it. Now I need to send it. So there's a method called send that'll get returned here. And when you send it, you need to tell it what account it's coming from. So I'm going to send it from my account because I'm the one interacting with the contract. And remember, we pulled the account from Web3 up over here from our wallet. So I'm sending that. And then I'm going to go ahead and you can then listen for these two parts of the contract to finish up, right? So I need to listen for one time when the receipt event happens. I think that's what it is, a receipt event, if I remember that right. So it's an async method here. I'm going to get my receipt. So semicolon there. And when I get that receipt, this receipt is going to give my contract address. So now I can go and save the contract address. It's going to be equal to the receipt.contract address. Bam. There we go. So now I've got this contract address for later. Okay, so now I've done that, right? So now that I've got my address, I can create the contract that's going to that I'm going to interact with, right? So let's go ahead and do this. I'm not sure I did this right. I don't think I did. It's okay. We'll figure it out. We'll figure it out. So now I'm going to go ahead and create my assets, my geo asset is equal to my new web3.eth.contract. Again, I'm going to pass it my API and my contract address. Bam, like so, right? So now I'm getting the contract that I deployed in here, right? So this is my contract address in here, right? So that's going to work. So now I've got that. So this is my contract up here. I might not even have to do that. I might be able to just interact directly with my contract at this point. But it's okay. We're gonna do it this way, and we'll come back to this in a moment. So now I can do const, and we're gonna go ahead and do an apply edits here. So I'm gonna wait on my layer dot apply edits. Right, so we'll come back to this in a second. So what am I waiting for here? Waiting for the add feature results. I think it's just, yeah, like that. I don't think there's an S in there. Okay, so what am I passing in here? All right. I am passing add features. And I'm going to pass one, the attributes. And there are a couple attributes here. This is I already know the attributes for some of the things I want to populate here. So I have an incident type, and I'm just going to say 3, and there's an incident description. Incident description, and I'm going to hijack this incident description to store the contract address. That way, when I come back to this, if I ever come back to this feature later on, I can use this contract address, get the contract from here, and then find out what the values stored in that contract are at a later time, right? So that's how that would work. So now what I can do is I can go in here and I can just say geometry. Actually, you know what? I don't think I need this here. So let's just comment that out. If I need this later on, we'll come back to it. I don't think I need it at this point because I have my contract right here. Actually, no, yeah, I do. Because if I come in, if I click again, then what's going to happen is that I'm going to just, this contract's already been updated, right? Yeah, I think so. We will see. I think I'm okay. Don't mind me. I'm being ridiculous here. Okay, so geometry type point, and the latitude is going to be lat, and longitude is going to be lon. Damn. So okay, so I've done that. This is why I like having some extra line space in here. So okay, so now what I want to do is we have one more function left on the contract to interact with, right? The update, and I want to give it the global ID that I get back when I've done my edit. So let's go ahead and get my edit. So I'm going to do const. It's going to be equal to add feature results 0, and it's in here that I want to go ahead and grab the global ID. Awesome. Okay, perfect. So now what I want to do is I want to await. I'm going to interact with this contract again. And if you want to interact with the methods on the contract, they make this really straightforward, man. It's in an object called methods, right? And on that methods, I have an update. Remember that was a, if I come back over here, there's a public method I can interact with. So I've got update method, and that update method takes my global ID. And at this point, I need to go and send that again. Remember, it doesn't actually do anything until I send it. There's also another way you can do this that does not cost anything. But in this case here, I'm doing an update to the contract, so I need to send so that I have to pay a gas fee to update this contract, right? I'm doing something to mutate the state of my contract, meaning that's going to cost me some network access, so I need to pay a gas fee, right? So that's why I have to do a send. So now that I've sent it, now it doesn't cost me anything once I have the contract to read data off the contract. That is free, right? So let's go ahead and get the latitude. I spelled that wrong. Some latitude with your attitude. God damn, I can't spell. There we go. Latitude is going to be equal to await geoasset.methods. And remember the properties up here, lat and lon, are public, so they fall under the methods here. I know it's a little odd, but that's how they are. And then I can call, and that is free. Doesn't cost me anything to make that particular interaction with the contract at that point. So let's call this longitude. There we go, and lon. Okay, now at this point, I'm going to go to console this out. So console.log, and it's going to be our lat lon. And if I want to do something with these in terms of I don't know, make a copy of them back in my feature layer or something like that. Remember, they're strings when I get them back, so I need to turn them back into numbers or something like that if I wanted to. And I don't have to at this point. So okay, and a lot of work. All right, let's go ahead and run this app and let's see what happens. Open up the network. Oh, sorry, DevTools here. Starting. So compiled with warnings. Okay, so here we go right away. When the application loads, I am interacting with my account, right? My wallet. I'm automatically creating a contract, and I'm getting the account information. So when I do something like get accounts, I'm authorizing my application to access my MetaMask wallet. All right, so I'm going to connect it with MetaMask. So you pick what account you want to connect it to, you verify it. Again, to verify, it's connecting, and now I'm good to go, right? So, okay, so now I've connected with it, I've loaded my map. So now what I can do, let's go somewhere far away. Let's come over here. Let's come over, yeah, up here by Devore Heights. That's good. Cannot read property deploy of undefined. 66. Okay, let's come over here. Contract. Did I not set contract over here? Contract. Yeah, it was trying to tell me that that was not legit, but okay. All right, it's okay. Let's try it again. So let's come back over here. Let's try this one. Radix argument. Okay. Oh my gosh, I put a 0 in there. What am I doing? It's ridiculous. I make stupid mistakes sometimes, people. Anyone that's watched my videos knows I make some pretty dumb mistakes. So, okay, let's put this back over here. Yeah, there we go. So, okay. So now this is verification that I want to go ahead and create. See, so there's my asset, my apply edits here, this one. So this is where this is coming from, right? So this is my deploy here. I'm deploying my contract. I passed my lat long, so I need to go ahead and verify that I want to do that. So I'm gonna confirm. Notice I have a gas fee here, and this is a network fee to use the Ethereum network. So confirm that. All right. So now that I've done that, I need to go ahead and run my update function. So that's another gas fee I have to pay here. So I confirm that. And there's the latitude and longitude that were stored in the contract. Right, so if I come over here to the JavaScript API, the SDK, remember I'm using the same data set here. Let's go ahead and let's zoom out. Oh, it's not gonna do it for me. Okay, hold on. Let's do this. I think this might work. If I open this up here, let's open the ArcGIS.com map. Let's open the map viewer. Let's come down over here. It's gonna complain. So somewhere around over here, right? So where was I at? Here, this one. So yeah, this point is this point here. So if I click on this, there's the address for the contract that I created for this one, right? That's how you do it there. Bam. And if I come over, I think maybe I can see it in Ganache here. If I go transactions, I can just see the transaction. I can't actually see the contract itself. All right. No logs either. Well, I mean, the logs aren't going to tell me anything. Bam, there you go. So now I have stored that point on the blockchain in a contract with my application. Let's come back over here. All right. Yeah, so I mean, okay, so I mean, I know it's not a lot. So okay, so I know that's not an awful lot that I've done with the contract, and I don't even know how, like, realistically usable that is to create a smart contract just to hold a point of something I'm adding to a feature layer to my edit or something like that, right? But I think it's kind of interesting. It's just kind of a first step to do some stuff. And so that is an Ethereum smart contract I'm working with. There's other types of smart contracts, oracles and stuff that can do a lot more that I think are really interesting. And I'll take a look at those next week because I think they bring a lot more to the table than just like a regular contract. Regular contract is fine for something like this, right? Any kind of asset tracking, validating ownership or something like that, I think is a perfect use case for something like this, right? When you deal with Oracle, it gives you a little bit more use cases to call external APIs and stuff. I don't know how much gas fees or something like that cost. Yeah, I don't know. I need to try it out and see what that would look like. But you can already see why something like this use case might deter people from using it in an application like this, because every time you deploy and update contract, it costs a gas fee. And on my local blockchain, it's not a lot. I mean, it's like a couple of bucks here and there. I wasn't seeing any prices here, but if I use a Brave with MetaMask, I was seeing like $7, $6 to do some of these updates, which is already pretty pricey. If you're running this live on the Ethereum blockchain today, the gas fees are going to range anywhere from, like, depending what you're doing, between $50 to $80 per transaction. And that depends on time of day, because it depends on how congested the network is that day, how many people are doing trading and stuff like that. And yeah, the gas fees get kind of nuts, right? It's a problem with Ethereum, but there's supposed to be a solution coming to that, maybe end of summer. I don't know. And I don't know how much it's really going to help with gas fees. If Ethereum gets their gas fees down to something like $10, I think it'll really help a lot. But it is the first market, right, for this kind of stuff, for making these smart contract stuff. So that's why it is so popular. It kind of paved the way for everyone else to come across and do things. Cardano is going to be deploying smart contracts, I believe, later this year. That's going to be really interesting, really fun, and it'll be easy to kind of migrate your contracts you wrote for the Ethereum blockchain over to the Cardano blockchain. And they promise gas fees are going to be much lower, more realistic places, hopefully a few cents, something like that. Binance Smart Chain probably costs just a few cents right now per transaction. I haven't tried writing anything with the Binance Smart Chain. I don't know if I have to do anything different with my contracts, or I don't know how to run a local Binance Smart Chain just yet. I'll figure that out at some point. But again, I just want to kind of give you an idea, some ideas you can do, working with the blockchain, working with your apps, and building them. Once you wrap your head around writing these Solidity contracts, it's actually not too hard. The key here is, remember, not to do anything too complex in Solidity contract. I have been told you do not want to iterate arrays inside of a Solidity contract, because that will increase the gas fees. Like, the more work you do in a contract, the more the gas fees are going to cost, right? And especially if your contract is interacting with other contracts and doing some other work in that way, yeah, that really just increases gas fees even more. So you kind of want to avoid that. You just want these very simple apply properties, validate some data maybe, and then that's it. That's all you want to do to keep those fees down. Right, so I recommend using remix.ethereum.org to learn that. If you really want, go over Solidity Docs. I have not gone over all the Solidity Docs. I go to them when I get stuck somewhere and kind of try to figure out what some of my error messages might mean, or some of these warnings I get might be. So that's when I end up in here. Remember, again, I showed you Truffle has these Truffle boxes. If you want to try them out, they're pretty interesting and pretty useful. So one place I've gone to, one YouTube channel that really got me started on here, is this DAP University. This guy Gregory here, he does sell like a boot camp, something like that you could sign up for. I have not, right? But I did. I have watched a handful of his tutorials. He's got some pretty long form blockchain tutorials on here on building blockchain applications that I've gone, like, probably spent 5-6 hours watching. So he's got a lot of really cool stuff. He really got me started on here. So I recommend, if you want to check it out, check his guides out. And there's plenty of other YouTubers out there that have some good content, especially for like Chainlink and stuff like that, which I'm also going to be looking at down the road. So there you go. That is how you can write a smart contract to interact with your ArcGIS API for JavaScript apps. I hope you found that useful. I'll be doing more content like this down the road, because I really have gotten into the tech and writing these smart contracts, working with blockchain stuff. I think it's pretty interesting, so I'll do more of these down the road. If there's anything particular you want me to cover, just go ahead and leave a comment down below. Remember, don't forget to comment, like, and subscribe to help these videos out. Thanks a lot.